introduce Professor Wang Xudong in brief. Okay, Professor Wang, he got his master's degree in mechanical design from Chongqing University, 2006, and got his doctorate degree in mechanical design from Chongqing University, 2009. From 2007 to 2008, he started in the Department of Wind Energy Engineering of Technical University of Denmark. Okay, from 2011 to 2016, he works as a postdoctoral researcher in CTBU. Now he is evaluation expert of National Nature Science Foundation of China, council member of Chongqing Graphic Society, and his main research fields are dynamic analysis of mechanical structure, multidisciplinary optimization design of mechanical structure, and key technology of wind power generation, and intelligent vehicle control technology. Okay, right now he takes charge of several national and provincial projects, and he has published more than 30 academic papers as the first author. Okay, today our Professor Wang Xudong, he wants to give us a report the industry development and the key technologies of wind power. Okay, let's invite Professor Wang to give us the report. Okay, please.
Okay, thanks for the introduction. Thanks for the Dr. Xu's introduction. Good morning, Professor Diego and everyone. It's my pleasure to share my recent research with everyone. I'm from Chongqing Technology and Business University. Worked at Mechanical Engineer College. The topic of my presentation today is industry development and key technology of wind power. There are three parts I will discuss with everyone today. The first is present situation of wind power industry. The second part I will discuss with you about the development trend of wind power industry. And the last part I will discuss with you about the main research works of our team. First, I will make some introduction of wind power. Wind energy is a clean and pollution-free renewable energy source, which is widely used all over the world. Wind is a new energy source with great potential. Global reserves are very huge. For the wind turbine, it turns the connect energy to the electric energy. So this is called the wind power generation. Wind power is very popular in Finland and Denmark, which have very long coastline and very rich wind resources. In China, the wind turbine is very popular in western and coastal area. The working principle of the wind turbine, like the figure, is the wind through the rotor and the growth gearbox and the electric generation and the yaw system. The wind turbine rotor changes with wind direction. So there is most part of the wind turbine. The currently situation of the wind power in China is like this. China generated 8,000 billion kilowatt hours of electricity in 2021. The thermal power generation with coal is a main part of the electricity. About 71% of the electricity generation of China's. And the second is hydroelectricity power. About 14% of the national power generation. Wind power is about 7%. Nuclear power is about 5%. Solar power about 2%. The proportion of clean energy varies greatly in different countries. The proportion of clean energy in China is relatively low compared with the developed countries, like Germany. In Germany, the wind power and solar power is about 25%, much more than China. And in UK, is also reached 18%. In 2021, China installed wind power capacity reached a new higher capacities. From the figure, we can see that the added wind power from 2011 to 2021 in China. We can see the growth is very fast year by year. Among the onshore wind power account about 70% of the new installed capacity, and the offshore wind power added 25% of the new installed capacity. In the second part, we will discuss about the development trend of the wind power industry. First, I will talk about the global energy development trend. From the Global Energy Outlook 2022, we can see that there are more energy policies to improve the energy efficiency. In the Global Energy Outlook, it is very obvious that the solar and wind power will play a very important role in the energy and climate goals. In the long-term projection, we imagined that there are fastly growth in both solar and wind sources. From these two pictures, we can see that the solar and the wind power will grow very fast in the future. This is a plan. This is a plan of the most Europe countries. For the wind and solar power development trend in from 2020 to 2050. This picture is about the offshore wind turbine development in Europe. From the picture, we can see that most countries in Europe will put more attention on the offshore wind turbine. That is a developed trend of the Europe. So how about the development trend in China? The National Energy Administration released many electric places in China. The new installed solar and wind energy is much more in China year by year. China has announced the policy about carbon peaks and carbon neutrality. To achieve the two goals, we must develop the new energy, so it gives much more chance for the wind power. There are some data of the wind power in China. The last part, I will talk about my recently research. Firstly, is we present an integrated method for design the wind turbine air force. In the picture, we can see it's a wind turbine air force. To get more wind turbine air force with super performance, one optimized model is presented by our team. Firstly, we presented an expression of the wind turbine air force based on the conformer maps and Taylor series. This is the function can express the air force. The optimization models is constructed by our team. The design objective is left and drag coefficients, and the design variance is about the coefficients of the function which can express the airflow. With the optimization models, we get some air force with different thickness. There are three new designed Air Force from our research team. To show the performance of our Air Force, we compared with performance with we compared the performance with other Air Force, such as NACA, which is very popular used in USA. So this is left of the Air Force we designed much more than the NACA. The second compared with the Risu Air Force, which is designed by the Denmark. Also, we compared the performance with DU Air Force, which is designed by Holland. From the compared, we can find that our Air Force has much more super performance than the popular Air Force. The second part is about the shape of optimization series of the windbane blade. Based the three series, we also consider the dynamic structure models of the windbane. In this model, 11 degrees of freedom of the windbane is considered by our team. The aerodynamic code is designed by our team for compute the aerodynamic performance, such as output power, and torque and thrust. In the optimization models, the objective function is designed by the cost of energy. First, we compute the cost of the rotor. The second part is AEP. AEP is average energy of the windbane per year. The design variance is the shape of the windbane blade, such as the chord, twist angles, and relative thickness. Firstly, we make an optimization of about 2 megawatt rotors. This is a result about our optimization rotors. Firstly is a chord compared with original and optimized rotors. Second is a twist angle. From the picture, we can see that the optimized rotor, the chord of the optimized rotor is reduced compared with original rotors, which can reduce the cost of the energy. This picture is a power performance of the of 2 rotors. We also compared the force which on the windbane blade and the different wind speed. The 2 direction forces is compared. which can show the optimized rotor is better than the original rotors. For another example, we also make a 5 megawatt 这个wind turbine rotors. This picture is a chord and twist angles distribution of the rotors. The third part is something about our the performance test method of for small wind turbine blade. We know the wind turbine blade is very long. Now most wind turbine blade is more than 100 meters. So we make the a small wind turbine blade for the test. One 2 kilowatt small wind turbine rotors is designed for our team, which is just 1 meter long. This is a chord. This is a twist angle. This is output power about our designed small wind turbine rotors. Firstly, we built the solid model of the blade. Then we make the manufacture process of the blade. This is a mood, yeah. This is a blade we manufactured. With a bladed, 3-bladed, we assembled wind turbine rotors and different wind speed. The output power is tested. We also compared the output power with other popular rotors. This is our designed rotors, and this is existing rotors. So we can see our designed rotors have more output powers. That is because our rotors have a very super performance air force. So the output power is much higher than the popular rotors. So that's all. Thank you.
Okay, thank you. Thank you for our Professor Wang. Okay, let's pass to the question time. Okay, do you have any question you want to communicate with our Professor Wang?
Hello, Professor Wang. Can you hear me?
Okay.
Oh, thanks for your lecture. And I would like to raise some questions here. The first question is, as the wind turbines gain more power, the blades grow longer. So what are the key technologies in the design and the manufacturing of high power blades?
Okay. Thank you. From this picture, we can see that the wind turbine with increase of the wind power, the length of the blade is much longer. Now the blade has exceed more than 100 meters. So the aerodynamic and reliability analysis of blade is very important. The two research area is also become very important part of blade for many research. Consider the cost and the process. Intelligent production is also an important research direction. Thank you.
Oh, okay, I understand. The second question is from the report, we can see that your team has designed some wind turbine air force with superior performance. Do you have test validation or industry applications for the designed air force?
Okay. We can see that we had designed 3 air force from our research team. We compared the performance with other popular air force. We also conduct the wind tunnel test. The aerodynamic properties are varied and compared with popular air force. We also applied for some invention patents to protect our design ideas. Due to the cost problem, there is still I think there is still a certain distance for the industry application of our Air Force. Thank you.
Okay. Thanks for your explanation. That's all my questions.
Other question, please?
Okay. Any other question?
Please, yes. Thank you, Professor, for your lecture. Please, Professor, what program do you use for design the turbine?
Okay. Okay. We for design the Air Force. Firstly, we make the function of the Air Force. Yeah, the function. There are many. There are many configurations about the function. So we select 6 configurations about the profile. Yeah. Then we created the optimization models of the Air Force. For the slew, we use some optimization tools in MATLAB, so we can get some new Air Force. Okay.
Okay, thank you.
Okay. Thank you. Thanks for Professor Wang. Okay, I hope it seems very interesting. I hope your team's design will using to the industry application very soon. Okay. Okay, because of the time limitation, I think it's end for us to say goodbye to each other.